All right, I pulled up your Chapter 5 book, and those of you that have a book, follow along. We're going to talk about the first part of statistics and what is statistics, and we'll start that in just a second. Let me pull this up and pull this back down and go here. Okay, there we go. All right, when you're talking about statistics, what is statistics? Well, statistics is the actual gathering, calculating, and evaluation of what? Numbers. Evaluation of information and evaluation of numbers. In other words, you gotta be able to start somewhere. You can't just pull numbers out of the air and say, okay, this is what we're going to base everything on. You gotta find numbers from the past. You gotta find studies from the past. You gotta get studies, observations or studies of yourself by yourself, and then take all that data, crunch it up, and find out what it's telling you. For instance, this is not mathematical, but how many of you have ever been on a 2-lane highway, let's say Wild Hog Road? Wild Hog Road is 187, goes to Pendleton, off 24 up here. And you get on that highway, you got an 8 o'clock class, and it's 7:30 in the morning, and you get on that road, and you get behind the little blue-haired old lady. And you get up to Pendleton, and there's 2 ways you can go. You can turn to the right, you go to Sandy Springs, you turn to the left, and go to Pendleton. Which way is that little old lady going to turn?
To the left.
To the left. Why? Because that's where you're going. And she's going to stay in front of you at 35 miles an hour until you are absolutely positively late. All right? And that's her goal, right? That's her goal that morning, was to make you late. No, it's the way you're interpreting it. All right? Now, you also predicted that she was going to turn left. Why? Because of Murphy's Law, because you are running late, and 2, there's only a 50-50 shot that she is going to turn left or right. So, and you predicted it correctly. So, that is taking data that you know of, experience that you know of, and you are putting it to, okay, we're coming up to the red light. I bet you $10 she's going to turn on her left turn signal. And just as soon as you say that left turn signal goes on. Now, you've done that before. You may not have done it in Pendleton, but you've done it because you ran late, and you've got behind a car, and that car will come up to a red light, and it can either go right or left, and you predict what that car does in your head because of what's happened in the past. And that's what you're doing here. This is probability. This is what we do in Chapter 6. But you can't do this unless you know how to do this. And that is taking values, taking experiences, taking studies, and reworking the numbers to see what is going to spit out. Okay? So that's what statistics is. Statistics is the preceding part of probability. Gathering of data, evaluation of data. So, let's talk about what they're talking about in your, right here. Statistics is the science, collection, and organizing and interpreting of data. Golly, that's what I had up there. So, write that down. That is a definition that you will be tested on. So, write it down. And statistics is also the data that you're studying. So it has kind of, statistics is a broad course, and it's also the data that you're organizing, calculating, and interpreting. Population. There's 2 things in statistics that you need to be aware of. Well, there's many things, but the first 2 things is population and sample. population has to do with the big part. So if I wanted to know how many people at Tri-County Tech were in the Marlboro Club, that would be Tri-County Tech students in general. That would be all Tri-County Tech students. That would be the population. What would I study? Would I study the whole population, or would I study a sample? I would study a sample. So I would study a sample, which would be maybe 3 classes at the Pendleton campus, 1 class at the Anderson campus, and 1 class at the Easley campus. That would be my sample. 5 classes, 3 at the Pendleton campus, 2 at the community campuses. 1 at Anderson and 1 at Easley. So that would be 5 classes would be my sample. Why would I not collect data on the population? It's impossible for one. Too broad, too much time, and too much. Talking about time, in the real world, what does time mean? Money. Too much money. All right, so that's why you would not do the population. The population is the big guy, and the sample is the what? There you go. All right, now, with sample and population go a couple of words. All right? And in statistics world, there's 2 worlds. There's the sample world and there's the population. Population we don't talk about too much, or we don't spend a lot of time in the population because it's unheard of to go out and sample and go out and do a survey of the population. It's just unheard of. So the population is kind of like what we strive to, or what we strive to predict, but the sample is what we work with. Now, with the sample, there's formulas that we use and variables that we use, as well as the population. But the formulas are the same. Okay? The formulas are the same, but different variables. Now, what are the difference between the variables? Well, with a sample, if you're talking about a mean or a standard deviation, you're talking about X bar and S. And the S is usually italicized. So if you're sitting in a meeting 5 years from now or 2 years from now, and you've got your graduation degree and you're in the real world, and you're going through a PowerPoint presentation, or you're following along a PowerPoint presentation, and you come up upon the mean X bar or the standard deviation S in the PowerPoint presentation, or the notes that you're given, then you know that they are talking about what? Sample. And that's something that you probably assume that you know. In other words, if they're talking about it, say, let's look at X bar, let's look at the sample mean. Well, the sample mean, you know in your head, that's a what? A statistic, because it belongs to the sample. Statistics belong to the sample. And parameters belong to the what? Population. And then you go down in the presentation, and the PowerPoint or the presenter says, well, and we also found that mu and sigma is equal to blah, 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 blah. And when they revert to mu and sigma, you know they're dealing with the what? The population. So the whole point of a statistic and a parameter is just so the reader or the person that's being presented to knows that you're dealing with a sample or a what? Population. So that's the only reason you've got that definition in there about a sample, a statistic and a parameter. Now, what would you not want to do? Well, you wouldn't want to go to a meeting or whatever and say, well, you know, I don't understand why your X bar is equal to 5.7. Well, if you said X bar is equal to 5.7 and the mu is equal to 5.7, the presenter would go, well, you're wrong. The mu is 5.7. The standard deviation, the sample mean is 3.6. And then you're going to look like an idiot because you're mixing the two up. So that's why it's very important that you understand that if you ever see these two guys in a presentation in a booklet, in a book, you know that it deals with the what? If you see these two guys, you know they deal with, and that's the only reason you have these two words, statistic and parameter. Really, statistic and parameter, really you don't need to know. You just need to know what it has to deal with. It has to deal with variables and formulas. If they are in a Greek letter, then you're dealing with population. If they're in a regular letter, alphabetic, whatever, then you're dealing with a. Okay? Comprende? All right.
Is that M supposed to be a long one? Okay.
Yeah, it's called mu. M-E-U. And sigma. And dang old what a cow says. Mu. Miss Wilson, you awful quiet back there. You sick? Okay, you're just in a bad mood. Why are you in a bad mood? You what? You're daydreaming. Well, you're not supposed to do that in my class. Well, that's right. You are here, so I'm not complaining. At least you're here. All right. So let's talk about something else. That's population and all that. We'll talk about that. And of course, this is all. Oh, come on, really. And process of statistical study. We're not going to worry about that. We're not going to worry about that because I just talked about that. Not going to worry about that. Random sample. What is a random sample? Okay, on page 290, green box. What is a random sample? The key word to the definition of a random sample is the last part right there in the sentence. I want you to highlight that or write it down. Because if you see that in the definition, that's a random sample. A random sample is pretty much anything that has a what? The last part of that sentence. Equal what? Equal chance of being selected. Highlight that or write that down because that's the most important part of the definition of a random sample. A random sample is a sample where any participant or any object of the sample has an equal chance of being what? Selected, Hubert. That's right, class. All right, so how would I make a random sample out of you in here? Anybody want to take a guess at it? How could I make it to where y'all were being a random sample? In other words, how could I make it equal for all of you? Okay, pull your names from a hat. That's the best example. In other words, put all your names on. Each one of you have a piece of paper that's 1 by 3. Each of them got to be the same size. Why? Exactly. If one of y'all put y'all's names on a piece of notebook paper and fold it up 15 times, is it going to be different from the other people? Yes. And then the person is going to feel that and go, let's see what this is. And they're having more of a chance of picking that one, or more of a chance that they're not going to pick it because it's different from the other. So everybody would have to have the same sheet of paper, and you put your first initial and last name, not anything else. Just first initial and last name. And then you would fold it up. You fold it in half. You wouldn't fold it 15 times. You just fold it in half and drop it in the hat. Then you shake the hat up, and then one person picks one. That is a random sample. Everybody has the same chance of being picked. Now that is very important. That is very, very important that you know that because that is a test question. That will be on the test. All right, so make sure you understand that. Systematic. What is a systematic? Have you ever been in a classroom, especially in science, and the teacher wants to put you in groups all the time? And the way they do that is everybody counts from 1 to 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then all the ones sit together, all the twos sit together, all the threes sit together, and all the fours sit together. That's called systematic random sampling. When you are every third person, every fourth person, every first person, every second person, that is systematic random sampling. Why? It has a what? System. There is a system. Convenience sampling. This is the worst one. That is the one that is the least reliable. Why? Well, I like to say, a radio station did a survey on its people that list on its listeners and wanted to know what kind of music they listen to.
It's not biased.
Why?
Because they're all listening to that radio station.
And that radio station is playing rock music. What they gonna like?
Rock music.
Exactly. So that's convenience sampling. You're doing a convenience sample, and you are pretty much dictating what the outcome is, or you are doing a convenience sample, and you're not going out of your own little world to find out more. You're doing a convenience sample of your own little world, and that's what that one is.
So it's not right.
No, it's not. We choose a sample that is convenient to select, such as people who happen to be in the same classroom. Okay? If I was to ask, let's say if I wanted to find out how many people were interested in engineering, and I said, well, I'll just use this class right here as an example. Why would that be biased? Why would that be convenience sampling? Because what is 103? It's not from engineers. It's for business and liberal arts majors. So what would everybody in here say to engineering? Sucks. That's pretty much what everybody would say in here. Why? Because that's exactly. You're not in this class to be an engineer. You're in this class to be the other side, the liberal arts, the business major. So if I ask the question, how many students at Tri-County Tech want to be in engineering, and I use this class, it would be very unreliable because everybody in here would say engineering sucks, pretty much. Because y'all are not engineering majors. Okay, that would be a convenience sample. Stratified sampling. This is when there are clusters. No sneezing, please. If I was to divide the group into Republicans and Democrats, that would be a stratified sampling. Or male and female. You having problems back there, Miss Wilson? All right. Make sure you know those, especially random sample, because that will be on the test. Here's some good examples right here. Systematic, this is a random sample. A computer going through all of the telephone numbers in the book and picking out one. That's a random sample because everybody's phone number is in there because it has the phone numbers for all of the phone numbers in the book. Convenience sampling. Hollering out your window, hey, do you believe in the death penalty? It's very unreliable because most of the people that you live around or most of the people that you talk to a good bit, chances are they're going to know how you feel about the death penalty and you're going to know how they feel about the death penalty because you've talked about it. So that would be unreliable. Systematic, that's reliable. And stratified, that's reliable. But the least reliable is the convenience sample. Alrighty. What is bias? Yeah, you're against something, or you're trying to show something, or in other words, it's weighted.
You have like feelings on that.
What if I told you, and this is kind of where you can be biased and use statistics and use a little bit of lying. let's say that I go across the United States and I study people and I send out this questionnaire and I go across the United States and I ask if the next president is going to be Republican or Democrat, and I come up with, golly, I've interviewed 1,000 people and they say 75% say that the next president's going to be Republican, which I doubt. But anyway, that's what I come out with. And I said I went across the nation, across the United States. What would you say? You'd say, well, that's pretty valid. But the states that I went to were South Carolina, Georgia, Mississippi, Alabama, Texas, and California. Did I go across the United States?
Yeah.
Yes, I did. I went across the southern half. But I went across the United States. But what was wrong?
Most of those states are Republican.
And most of those states are conservative, yes. Most of them are Republican, except for California. Is that biased?
Yeah.
Yeah. And I'm misleading you also because I'm telling you that I'm going across the United States. There's a lot of surveys out there that are biased. There's a lot of surveys. That's why you have to do your own research when you're talking about surveys. You have to do it because you can get biased thinking out there. A lot of people consider the mainstream media to be biased. Is it?
Depends on what you're
So yeah, well, some people. Well,
watching. Fox is biased towards conservative.
yep.
NBC is biased towards liberal.
Well, most of the mainstream channels are pretty liberal. So then they elect the president of the United States also, which I think they do. Anyway, take a look at this. 292, observational study and an experiment. If I look at a mouse in a maze, is that observational or is that an experiment? Well, notice I said look. If I watch a mouse in a maze, that is a observational study. Now, if I put cheese or something in there, or I change the observational study, or I do something, then that changes everything. If you have some kind of activity in the study, then you have changed it from a study to a what? Experiment. You ever seen these people in sleep apnea labs? You ever seen them on camera? Oh, you need to watch them. You ever seen them sleeping? That's funny. You don't want to see yourself sleep. It's pretty funny to watch yourself sleep. Not with all the twisting and turning, but then some people sit up, lay back down. But what do these sleep apnea? What do they do? Do they do an experiment or do they observe you? They observe you. It's an observance because they watch you. They watch your heart. They watch your breathing. They monitor everything. Do they affect you sleeping? No. They don't sit there and send electricity through your body and see if you wake up. They don't pour water or hold your hand in warm water and see if you don't pee in the bed. They don't do anything like that. All they do is watch you. If the event is mostly watching or observing, then it's going to be an observed event or an observed study, observational study. If you take part in any way in the observational study, then it becomes an experiment. Okay? What would be an experiment? Well, let's say that I divided the class into two groups, this side and this side. And I gave this group, Miss Wilson's group, I give her, them group, I give them a white pill. And I say that white pill will do this, this, and this. And y'all are in another room. And I give them that white pill, and every week they come into class, every Monday, we check on their status. And I give this side of the room, put them in a room, give this side of the room, I give y'all a green pill. And I tell y'all what the green pill will do, and I do check y'all out every Monday. Alright? Is that an experiment or observation? It's an experiment, because what have I given you? I have given you a pill, and this pill is a sugar pill, and this pill will make your head get bigger. All right, whatever, make you get smaller, make you get bigger, whatever. It will do something to your body. This one will not. I have affected the study. I have affected it. I have done something to it. So therefore, it becomes a what? An experiment. Okay. Make sure you know the difference between the two, and most of the time the question will give you a hint, like observed, look, watch. If you see those three words, which one do you think it is?
Okay.
Yeah. Okay. I'd get mad and leave too. All right. Treatment and control group. That's a treatment group is somebody that you're actually testing, that you're giving drugs to or a pill to or whatever. Control group is one that does not receive the pill. And that's pretty self-explanatory. I'm not going to spend a lot of time on that. And what is a placebo or the placebo effect? Anybody want to know what that is? Sugar pill. What is that?
That's when you give your sugar, it's not as an aspirin, it's a, you think it's going to take away the headache.
Yep.
It's like drugs.
When I was in the Marine Corps, we used to, when we were in Redstone down in Huntsville, Alabama, we were right out of boot camp and we were going to school, and we were about to graduate school down there, so we were going to have a party. So what we would do is we would go and to the local, it's called the Regis Hotel. It's one of these two-story hotels that you didn't stay for, you just partied in, okay? You know what I'm talking about? And we get 3 rooms joined together, and we had these 2 newbies. Newbies is somebody right out of boot camp. And they wanted to party with us. We said, sure, you can party with us. So we took them with us, and we passed out flyers and put them in the mall. We would put them on Honda Accords and Honda Preludes back then, because that was the girl car then. And we'd show up, there'd be like 5 Marines and like 20 women. So it's great. And we would, got the 2 guys, and said, we're going to give you y'all's own room. And that way y'all can trash it if y'all want to, whatever. We won't be, but it'll be joined on to us. And we'll buy your beer. We'll bought them a keg of O'Doul's, but we put a Budweiser tap on it. Now, what is O'Doul's? They passed out by 12 o'clock. They passed out before midnight on non-alcoholic beer. What was that? Placebo effect. They thought they were drinking Budweiser. And they drank themselves until they thought they what? Were drunk, and they passed out. They didn't have 1 drink of liquor, because all we had was beer. And they passed out before 12 o'clock on O'Doul's. So, placebo effect does work. It just depends on how you administer it. And some people will actually, have you ever heard of people losing weight and they wasn't taking a pill or anything? Or they were taking a pill, but the pill had no value whatsoever? That's the placebo effect. People, mind is a pretty strong medicine. It's a pretty strong drug. It can do a lot, especially when you drink O'Doul's. Better watch out, O'Doul's. It'll make you pass out. All right, and the placebo is lack of active ingredients or the treatment being tested in a study but looks and feels identical to the treatment. Those 2 Marines, they got drunk and they passed out. But did they pass out and get drunk because they were full of alcohol, or their mind was full of alcohol? Their mind, they were thinking they were full of alcohol. So the mind has a lot to do with placebo effect. Capiche? I'm not getting into all that. Skip that. Surveys and opinion polls. And make a note of the margin of error. Let's skip a couple of pages there. Margin of error is on page 296. What is the margin of error? Well, if I tell you that a survey is good within 2 percentage points, then you know it's a 98% to 102%. You know it's got a pretty good, 98 to 102%. That's within, or that's give or take, within 2 percentage points. That's what that means. Okay, so sample statistic of margin of error, put minus and plus. That's why when you see a poll and they say that 59% of the people say that Mr. Smith is going to be the next president, and 58% say that President Jones or Mr. Jones is going to be the next president. Why do the newscasters say it's a dead tie? If it's within 2% marginal, if the margin of error is within 2%, then what do those two, 58 and 59%? That's only 1 point. They're a statistical tie because the margin of error is 2 points. Now, what if one was 58 and the other one was 51? Then it would be landslide. But if one's at 52 and the other one's at 50, and it's 2, then it'd be a statistical. If it was 2 marginal points, and that's what that means. So it makes a difference what the margin of error is. The greater the margin of error, the less valid the data is. And that's 5A. Now those are what you wrote down today was the most important part of 5A. I'm going to try to test you on just those parts. Yeah. Thank you. Terms.
These tapes are on 9, correct?
Yep. All right. Should you believe a statistical study? This is where you have to watch out. They're getting into being biased, statistics, doing the work of people that are trying to get an agenda passed, people that put misrepresentative pictures on the screen. They do that. Some people use statistics in a unethical way. That's what it says. Consider the source. Look for bias. Look for problems. Beware of confounding variables. Consider the settings. Check the results are presented fairly. Stand back and consider the conclusions. So a while ago, I told you that I went across the country, across the United States, and I found out that the next president's going to be blah, blah, blah. All right? There's several things there that you assume. One, what did you assume? That I went and bought and I surveyed 100 people out of every state. That's what I led you to believe. What else did you assume? That I didn't have a bias. That I went and that I asked people, no matter what their religion was, no matter what their politics were, I just went and just asked people. I didn't care about that. So there's a couple of assumptions there that you had about my survey that you were wrong. And that's why it says get a good picture of it, do your research, and consider where it's coming from. If you got a survey, if you looked at a survey from the Washington Post, and then you looked at another survey from Billy Bob's newspaper, which one would you take more credibility in? The Washington Post, because you don't even know who Billy Bob is, much less Billy Bob's newspaper. Consider the source. Look for bias in the sample. Look for how they pulled the sample. look for the people that they asked. Did they ask a lot of people from up north or a lot of people from down south? Why would that make a difference? More liberal versus more conservative down south. So that makes a lot of difference. Check that the results are presented fairly. Sometimes on the news or newspapers, they will put graphics about the survey and they will be misrepresented. Okay? The actual numbers come out to be a little bit greater than 1 or 2% difference, but they'll show it like this side is huge versus this side, and there's only like 2 or 3% difference between the two. So that's something you have to watch out for. Make sure you read up on selection bias. That's going to be a question on the test. Selection bias. Every time they throw up I do watch Fox News a lot. Okay. Every time they throw up a survey, I usually question it. Why? Because if they say, we took a survey and these people really do dislike blah, blah, blah. I have a question about that every time I see Fox News throw up a poll. Why? Exactly. They're probably already asking people that don't like it when I do. And I'm a big fan of Fox News, but I always have that question in my mind about their surveys, just like I have a question in my mind about NBC's. Sometimes NBC has surveys, and I believe they only interviewed people in New York. I really do. I really do think that. Or California in New York. I don't think they interviewed people in the South, but we're ignorant. We're a bunch of racist, ignorant people anyway.
There is that they make it like this. People are good.
Yeah.
Bad,
Well, that's because we're all ignorant.
Yeah.
Yeah, we are. We're ignorant and racist.
Like on Fox News, they'll do it the same way.
Mm-hmm. Yeah, Fox News is the same way.
It's not a good or bad issue.
It's just, exactly. And that is, we're talking about selection bias. Participation bias is whenever people choose whether to participate. And you've seen this before. People will participate in a survey if it's going to get this person fired. You ever seen that? Or will you sign this petition to do away with this person? People will sign it in a heartbeat. But will you sign this petition because we want to give this man an extra bonus for his Christmas or blah, blah, blah? People won't sign it.
Sitting on the jury.
Yeah. And that's why being a jury selection is so important to trial. Because if there's any bias in that juror, it needs to be found. And it's interesting on some of the questions they ask you. They'll get down and dirty. They'll ask you all kinds of stuff. So you better watch it when you get on jury duty. Miss Wilson, you ever been on jury duty? I have. I was on federal jury duty one time, and this is no joke. The guy that was on trial for drug. He was a major drug dealer. He wasn't one of these on the corner in Anderson. He was dang old I-85, dang old Charlotte to Atlanta, dang old artery. Okay, and he was a major drug trafficker. And he said he was going to represent himself. And I'm sitting in the back of the federal courthouse, right there on whatever road that is, right there at Fayette Street, whatever. I don't know, Calhoun, whatever that is. Right there near the fire department. And anyway, I'm going to turn this thing down. It's bringing too much. There. And he got up and he said, I want to ask everybody in here there's about 50 of us in there for jury duty. And this was the only one we had. This is the only case we had. And he said, those of you who have used the N-word in your life, stand up. So then the judge said, okay, if you've used the N-word in your life, stand up. Well, about 3/4 stood up. And they asked us to leave. And they were the only ones that were left. It was about 10. There was about 10, 15 left. And that's who he had to choose from the jury, from those 10, 15. And the judge just sat there and shook his head. Because now he had these people, he only had 15 to choose from. So, I don't know how that... But that was my jury duty. It lasted about 15 minutes. I didn't even get to stay. I've never been on a jury. So, but that did my jury duty. So...
I did meet a guy in unemployment office, and he told me, and this is the first time that I ever heard this. He said that the people in Anderson County said that he was a menace to society. What he did, I don't know, but he was like.
Well, there's a lot of menaces to society. Yeah. Well, this guy was a menace to society, let me tell you.
Pretty smart though, he just weeded out half that courtroom.
Yeah, but it might not have done him good.
I don't know.
Because some of the people that he took out was his own race. So I don't think, first of all, I don't think I'm smart enough to represent myself in a court of law.
Or no.
Okay? I can argue, but I don't know the law. So I watched my cousin Vinny 15 times. But oh, what are you? A world traveler? Well, I love her in that movie. Anyway, a variable. A variable is any item or quantity that can take on a different value. Variable interest in a statistical study are the items or quantities that the study seeks to measure. Just remember, a variable is what you look for, just like in algebra. You look for the variable x. In a study, you're looking for a variable. Not real important, but you need to make a note of it. I think we're in 5B or 5C. 5B. So we're going into 5C. Somebody check the syllabus. Did we go to 5D, 5C? Tell me what sections we go in chapter 5. I'm sorry, what?
5C.
And then chapter 6? Chapter 6 should be after that, huh?
You have 5A, 5C, and 5E.
Oh, okay, well, here we go. All right. Statistical tables and graphs, 5C. Frequency distribution, or a frequency table. This is important because we're going to talk about this in chapter 6. Frequency table or frequency distribution is a head count based on classes. Just write down head count based on classes. Give you a second to write that down. Now, right now, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got 15 people in here right now. Now, the traditional way of, saying that is there's 15 people in the class. That's it. Now, what have I decided? How many blondes, brunettes, and redheads are in the class? Well, then I've just decided to turn this class into a frequency distribution. The classes are blonde, brunette, and redhead. Those are the 3 classes. And then the head counts will be how many blondes, brunettes, and redheads there are. Age. If I broke it up into age classes, 18 to 21, 22 to 25, 26 to 29, 30 to 32, blah, blah, blah. That's a frequency distribution. Classes are on the left, head counts on the right. Look on the page right here. Here's the same thing. This is a frequency distribution. A frequency distribution is a 25-cent word for head count broken up into classes. That's what it is. If I go by shoe size, below 6, above 6. If I do male and female, that's the frequency distribution. If I do blonde, brunettes, redheads, brown eyes, blue eyes, or hazel. Well, Hubert, there's more eye color than that. That's it in here. Okay, we ain't gonna go more than that. But there's light brown. Shut up. Brown, hazel, blue. That's it. Oh, green. I'm sorry, green. Don't forget green. Okay, I said hazel. This one. Brown, blue, green. There we go. Those three. If you're not those three, then you're gonna go in those three. One of them, you're gonna go into them. Hazel's gonna be green or whatever. We probably could throw hazel in there. Yeah. That would be. What about shoe size? Yep, we could do shoe size. We could do weight. We could do height. We could do hair color, eye color. Those are all classes that we could break it up into. And see, that is where people start to get kind of overwhelmed. See, I could say that out of these people, see, let's say that these are people that made grades on a test, okay? I could go through here and say, you know, I got 4 A's, 7 B's, 3 C's, or 9 C's, 3 D's, and 2 F's. Or I could go through and just list the grades like they did. There's 2 ways of listing. These are by grades, and this is a frequency distribution. Again, a frequency distribution is a 25-cent word for class and head count. This is kind of like probability, but the relative frequency is the number of instances over the number of trials. So, how many A's did we have? Well, up here we had, how many A's did we end up having? 4. So 4 would be 4 over 25. Where did 25 come from? That was total. So that would be 1.25, 1/4. 0.25 of the class had A's. 0.25 probability. One of my numbers was 9. I can't remember if it was C's. Was it 9 C's? That'd be 9 over 24. Or 25. So that would be your relative frequency on your numbers. I'm not going to worry about that too much because when we get to probability, that's what you're going to be doing. So I'm not worried about that too much. I'm not going to ask you to find the relative frequency until we get to the actual math. But they show you relative frequency right here. That's a good page to keep up with as far as relative frequency, page 311. About the only math we've talked about so far is that page right there. There's a test question right there. Qualitative data and quantitative data. Quantitative data and qualitative data. So if I was to go up here and write down qualitative or quantitative and qualitative. Quantitative could be like height. What else? Weight. Age. What else? Shoe size. What else? Huh? Eye color? No, that'd be qualitative. This would be eyes. What else? Hair. What else? Huh? Skin. Yeah, what color your skin is. Well, you could do that, yes. Color, skin, heritage, other things. We'll just go an arrow. You get the point. Versus over here, where you got what? Numbers. Quality, not what? Quantity. What does that mean? That means quality is the product, the actual, how well the product is put together. Quality. Versus quantity, which is quantity meaning more of the product. You always want quality, not quantity, but unless you're, excuse me, you ever wonder what the first McDonald's hamburger tastes like? Do you think the first McDonald's hamburger tastes like what you get at McDonald's today? Probably tastes like a Hardee's hamburger. Probably tasted like that. If you ever had a Hardee's hamburger, they're good. But it probably, or a Wendy's hamburger. But they've gone down a little bit too. They're starting to slam them together, and when you get them, they're all part of the bun is over here. And I tell you one thing though, Hardee's has got it going on with the hamburgers right now. But I'll show you. All right, let's look on the next page. Gotta get y'all through these reading chapters.
Well, quantitative is numbers, so qualitative could be.
Quality. Qualities about you, yes. And they give you examples here. Classify each brand quality as qualitative or quantitative. Brand names of shoes. Qualitative. Height of students. Quantitative. And audience ratings of a scale from 1 to 5, where ratings, I'm sorry. That would be what? Qualitative. Because they're saying they're good or bad. Good or bad. They're not saying if it's a good number, they say if it's good or bad. Good or bad is quality. Okay, qualitative. So you just got to ask some questions there to yourself. What are we measuring? And then ask yourself, is it qualitative or quantitative? Bar charts and pie charts. Make sure you know how to read them. Make sure you know how to calculate with them. I do put a question on the test, and I get people that miss it, and they go, "Oh, I didn't know how to read it." We've been on this for about 2 or 3 weeks now. This is last semester. We took the Unit 1 test, and you missed the graph question, and you said, "I didn't know how to do it." Okay, yeah. First of all, the difference between a bar chart and a histogram, does anybody know the difference? They're touching. In the histogram, bar chart, the difference between a bar chart and a histogram, if this was a histogram, the brown bars would be touching each other. That's the difference between a histogram and a bar chart. So there's no difference really, except that a histogram, those brown bars would be touching side to side to each other. That would be it. A bar's height usually tells you how many people are in that category. That one right there says 9. So that top bar, that middle bar, is representing how many people? 9 people. So you put a 9 on the top of that bar so you can count them all up, find n. And the next one to the left is 7, and the next one to the left is 4. So 11, so that's 20. Up to that bar, there's 20 people in the classroom. And then what's after the bar? 3, so that's 23. And then 2 more is what? 25, Hubert. That's right, class. So 25 people are in that classroom that represents the bars. Well, the pie chart, you have a different layout with the pie chart. Usually the pie chart is in what? Percentages. So if they want you to figure out the percentages, let's say that I make $1,000 a week and 28% of my paycheck goes to bar hopping. Well, then how much is that out of $1,000? 28% out of 1,000 is 280, Hubert. That's right, class. Thank you, class, for the interaction. So I spend almost $300 a month on bar hopping. Okay? And let's say I spend 8% of my $1,000 a month on gas. So how much is that? 8% of $1,000. What would that be? $80. So I spend $80 on gas to go bar hopping. And then I spend 40%. I'm just going to pull this out of the air. I spend 40% on C, which is going to restaurants. So what would that be? $400 a month. Yep. And then I moan and complain at the end of the month when I ain't got no money to pay the bills. Oh, I'm sorry. That was my next line. Oh, I'm sorry. So that's how you use the pie chart. You take the percentages and you multiply by what you got, and that's the money that you have. Are we through for today? Is that? What time's class over? Okay. All right. Let me shut off everything. There's that.